Hi, welcome back to A World of Code. This video is for going over the challenge questions that accompany Lesson 3 from our SQL Query Jumpstart Guide. Lesson 3 is part 1 of our video on simple select queries. Please note that these challenges are optional. They're meant to be fun exercises to give you more hands-on experience, but nothing in the main course will assume that you've completed these questions. You can get to this page by following the link in the video description, or the link in the description on the video for Lesson 3. This page contains the challenge questions for the lesson, the script to set up the database in SQL Fiddle to get started, and any other lesson materials that might be helpful. For every lesson that requires it, there will be a link in the video description that leads to a page similar to this one. The files included with each lesson might be different, but they should always come along with a list of challenge questions and a file titled build.sql. For this lesson, we've included it in this SQL folder. This is the file that sets up our database in SQL Fiddle, so we can get started writing queries and answering the challenge questions. In this lesson, I've included an employees.pdf and employees.xlsx. These files contain a table representation of the example database for this lesson. Once you run the build script and get set up with SQL Fiddle, this is the data you'll have in your database. I've included it here so you can see all the data at a glance, and you'll know if you have any problems with your database if the data you're getting doesn't match this table. The employees.xlsx is the same as the PDF, just in a spreadsheet format. In case you want to download this repository to your own computer, you can open this with a spreadsheet program. I've included both of these files because the PDF can be opened directly in the browser, but the spreadsheet file isn't supported. If you want to download any one of these files, you can click the download button in the top right corner once you've gone to the file in the browser. The operators.pdf just contains the table of operators that I showed towards the end of the lesson. Within the SQL folder, we have the build script I mentioned earlier and the lesson.sql. This file has everything I typed out during the lesson. So if you want to, you can play around and run these yourself or use them as a starting point for your own queries. Alright, let's get set up with SQL Fiddle. First, I'm going to open a new tab and navigate to sqlfiddle.com. In the top left, we need to select Oracle 11g R2 from the dropdown. From here, return to the previous tab and find the build.sql file I mentioned earlier. It'll be inside the SQL folder. Open that and select the contents. You can click and drag, or simply click Raw and then Ctrl-A to highlight everything, and then copy. Return to the SQL Fiddle tab, select the Schema panel, and paste the contents of the file. I should mention here that SQL Fiddle has a strange bug, where if you use a right-click and select Paste from the menu, it'll give you an error when you try to build the schema. So I suggest when you paste here, use Ctrl-V. Build schema, and schema ready. And that's it. Your database is all set up. Let's run a quick query to make sure. At a cursory glance, this looks pretty good. Looking at the employee ID here, we should expect that there's 23 employees. So let's take a look at our example table and make sure that matches up. And that looks correct. So just at a quick glance, everything looks good. We're not going to go over how to use Git in this course, If you're already familiar with it, you can use it to clone this repository. Otherwise, if you want to download these files, let's look at a few ways we can do that. If you want to download any of the files from this repository, there's usually a download button when you navigate to one of them in the top right. If your browser is anything like mine, it might open the PDFs automatically in your browser instead of downloading them. If it does that, then once you get to this page, simply press Ctrl+S on your keyboard and save it somewhere as a PDF. SQL files have a similar issue in that they don't have a download button at all. But again, if we go to Raw and then press Ctrl+S on the keyboard, we can still save the file in its original format. If you just want to download everything as a zip archive, simply click here on SQL Jumpstart to go to the root of the project, then click this code drop-down and select Download Zip. Keep in mind, the way this is set up, this will download all of the available lessons for the course at once. So as lessons are added, when you do this, it will come along with all of the previous lessons as well. So now you should be fully ready to get set up and begin answering challenge questions. It is at this point that you should pause the video if you intend to attempt these exercises yourself. Alright then, let's take a look at these challenge questions. Alright, first let me just get my Windows set up a little bit better here. Question 1. The email memo didn't reach some employees who don't have internet access at home. Get a list of all of the employees' phone numbers so we can call them as well. Don't forget to include their names so we know who's calling. Alright, let's go through this step by step. It's a select query, so we need the select keyword to start with. Then we need to decide which columns we're going to need. This question specified that we need their phone numbers and also their names. So we're going to grab the employee name column and the phone number column. I'm going to do it in that order because I think it's easier to read than if I did phone number first. Then the from keyword, and this is coming from our employees table. Now, do we need a where clause here? The question says we need to get a list of all of the employees. Now, what the where clause does is it lets us filter down our list of employees based on conditions. Since we're getting all of the employees, we don't need a where clause, because the where clause will always limit the number of results from our table, and here we want everything. So, this is the end of our query, and all we need to do is add a semicolon. And let's run it. And this looks like it's probably a list of all of our employees. At a glance, it looks good. If you want to, you can go through all these names one by one, but just looking at it, it looks like we got what we wanted here. And for columns, we have their name and phone number, just like we wanted. So that's question 1 out of the way. Easy peasy, right? Now let's take a look at question 2. Good news! We're going on an executive retreat. Get a list of all of the employees with the manager position so we know who will be going. Let's go take a look at our full table again. We see that our table has this position column at the end here, and that some of our employees have the position manager. So for this query, we want to make sure we're grabbing all of these employees that have the position manager and no others. So let's start off. As always, select. Now what columns do we need? The question doesn't specify that we need any specific information about them, just that they all need to have the manager position. So in this case, I'm going to grab all of the columns. I'll use this asterisk shorthand we went over in the lesson, and we're selecting from employees. And now we need to narrow down this list to only those who have the manager position. This is a condition on the column position. So here, I'm going to type where position, and their position needs to be manager. So we're going to be looking for employees who have a position equal to manager. And let's give it a run. Here we see that it's returned 3 employees and all of them are managers. That looks good. It's returned only managers, but we also want to make sure it's returned all of the managers. So let's compare this with our full table. We see that the managers are Sarah, Jill, and Lucy, and no others. So this is exactly what we want. Alright, on to question 3. Bad news, we didn't invite the CEO on the retreat. Please get an updated list of managers, which includes the CEO. Alright, let's look at our table to see what happened here. Here we see that all of our managers have the position manager, but the CEO has the position CEO. Since the CEO's position is CEO and not manager, they won't be included in the list that we have. We also need to include the position CEO. Since this continues from our last query, we'll copy it as a starting point. Now what do we want to do here? We want managers and we want the CEO. So what if we tried to use the AND keyword? We'll do AND position equals CEO. And let's try it. Nothing. So what's the problem here? This is very similar to the question we went over in the lesson, the one where we were looking for employees with a salary greater than or equal to $150,000, but we also wanted to include Steve. If you remember, the conditions here need to apply for every employee that we look at, and there is no employee who has the position manager and also has the position CEO. I mean, that doesn't even really make sense. We're talking about the same column here, so it can't be both things. What we really want is every employee who is either a manager or they're the CEO. So let's change this AND to an OR. Try running that. And we see we get the list we want. It's the same 3 managers as last time, but it also includes the CEO. Question 4. Some of our employees are starting to complain about all the phone calls. Luckily, it turns out that only members of the IT department lack internet access at home. Please select the names and phone numbers of the employees who work in the IT department. Okay, so this continues from question 1, where we wanted a list of all of the employees' names and phone numbers. So I'm going to copy that query as a starting point. But now we're adding the condition that the employees have to be members of the IT department. Let's take a look at our full table to see what that means. Here we have a department column, and we see that some of the employees belong to the department IT. So, since we're imposing this condition on our query to filter down the list of people we have, we need to add a where clause. And in this case, we're adding a condition to the column department. So we'll type where department. We need the department to be IT. So we'll be looking to select these employees where department equals IT. And let's run that. That looks pretty good. Let's double check the table to verify that these are all the right people. We have Ted, Tim, Victor, Samantha, and Frank. And our IT department should have Ted, Tim, Victor, Samantha, and Frank. All right, looking good. On to question 5. Could you please include Steve in that list of IT employees who will continue receiving phone calls? No, he got the memo. Why do you ask? This continues from the question we just did. So let's copy this query down and use it as a starting point. It's getting a bit long at this point, so I'm going to break it across multiple lines. Okay, so what do we need here? We need employees who are from the IT department, but we also want to include Steve. This is very similar to the question we went over in the lesson. In that question, we wanted employees who were making a salary greater than or equal to $150,000, but we also wanted to include Steve. The way we did that was with the OR keyword. Since every employee we wanted in our list either needed to be making greater than or equal to $150,000, or they needed to be Steve. In this case, every employee that we want to bug with a phone call either needs to be from the IT department or they need to be Steve. So here we'll add the OR keyword, and this is a condition on the employee's name, since their name needs to be Steve. So we'll look for that to be equal to Steve. Now when we run this, if it works, what we should expect to see is exactly the list we already have, but with Steve added. So let's try running it. And that's exactly what we get. So we know this is right. All right, on to question 6. Could you also include the HR department in that list? Why doesn't anyone have a computer? Okay. Again, we're continuing from the previous question. So I'll copy this one as a starting point. And now we need to also include employees who are in the HR department. So what we're looking for is employees who are either in the IT department, or their name is Steve, or they're in the HR department. So for this, I'm just going to add another OR keyword. And this is another condition on department. And in this case, department needs to be equal to HR. If you're trying to answer this question and you're wondering, how do I know what to put here? Just go take a look at the full table and look for employees in the HR department. We see that their department has to be HR. And let's run that. All right, we have quite a few people here, so let's make sure that this list is accurate. All of the employees we should be expecting are Fred, Hank, Sarah, Ted, Steve, because it's Steve, Nate, Justin, Tim, Victor, Samantha, and Frank. And the list we got: Fred, Hank, Sarah, Ted, Steve, Nate, Justin, Tim, Victor, Samantha, and Frank. So that looks good. And we have the columns we need. All right, on to the next question. Good news! We're giving raises to all of our lowest paid employees. Please get the names, salaries, email addresses, and phone numbers of all of the employees who earn $30,000 or less. But this raise is only for permanent positions, so please only include those who are full-time. So let's break this down. Start off with our select keyword. And what are the columns we need? The question specifies that we need names, salaries, email addresses, and phone numbers. So taking a look at the table, we need the columns employee name, salary, email address, and phone number. And we need it from all of the employees who earn $30,000 or less, but only if they're part-time. Let's start off with the first part. This is a condition on the employee's salary. So we'll start off And I forgot to add from employees, so from employees, as always, since employees is the only table in our database. And now we need to add the where clause. So where salary, and in this case, we're looking for a salary of $30,000 or less, so less than or equal to $30,000. But only for those who are full-time. Now, when you're looking for employees who meet a condition, but only if some other condition, that's another way of saying and. So for here, I'm going to add the and keyword. And this time, for full-time or part-time, that's a condition that's determined by the employee's employee type. So employee type, and looking at the table, for full-time employees, we need an employee type of FT. So employee type equal to FT. And let's run it. And look at that, we only have one employee. And I'm only now just noticing that Greg's email address is Gret. Well, let's take a look at our table to see if this is accurate. Let's go through the list, looking at all of the employees who make less than $30,000 a year, and see how many of those are full-time. Here we have $25,000 a year, but that is part-time. Here we have another at $12,000, and that's also part-time. This one's at $30,000. Nope, that's $300,000. $15,000, also part-time. $20,000, part-time. $20,000, full-time. And that's Greg, so we expect him in our list. And all the rest, oh, nope. And Sally also makes less and is part-time. So the only employee we would expect to see here is Greg, and that's all we got. So this is working as expected. Alright, I've included a bonus question. Now this one's a bit of a trick question, so if you didn't get it, that's okay. I haven't exactly gone over everything you need to know in order to answer this one, and I'll be doing that in a future lesson. So if you didn't get it, don't worry about it. So, as we did in our lesson, please select employees who are part-time or are Steve. But this time, only include those employees making $30,000 or more. So let's start off. Select. And we're not looking for any specific columns here, so we're going to use an asterisk to select all. We're selecting from employees. And we want to select employees who are part-time or are Steve. So for our where clause, we want a condition on employee type set equal to PT for part-time, or the employee is Steve. So, or employee name is equal to Steve. This is what we had in our lesson. But now, we want to make sure that everyone we have in this list is making $30,000 a year or more. So we need a new condition on salary. So, like I was talking about earlier, for all of the rows returned by this query, we need some condition to be true, but only if some other condition, which is another way of saying and. So on top of our or keyword here, we also need to add an and keyword. We need and employees making $30,000 or more. So a salary greater than or equal to $30,000. Now, if you've attempted this question, this might be what you tried. And if you did, you might have found that this didn't select for exactly what you were expecting. This does include Steve and then only part-time employees, but you'll notice that some of the employees make less than $30,000 a year. So there's something wrong with our query. And the problem is actually the order of these conditions. When we start to mix and match or and conditions, the order actually makes a difference. If we reorder this query to check that employee name equals Steve or employee type equals PT and salary is greater than or equal to 30,000, then we find that we get the correct result. I'll go over this in greater detail in a future video, but just as a quick explanation, the issue here is that conditions separated by an AND keyword are sort of grouped and looked at before conditions separated by an OR keyword. So if we look at how we had this before, this query is looking for employees who are Steve and earning greater than $30,000, or, aside from any of that, they're part-time. In this instance, the question of whether the employee has a salary of greater than or equal to $30,000 is never even applied to the part-time employees. It's only applied to Steve. So this query will actually return you a list of all of the part-time employees, and then also include Steve, but only if he makes greater than $30,000 a year, which he does. If we look at the correct version of this solution, with this condition on the employee type and the salary condition separated by the AND keyword, we've now logically grouped them. So we're looking for part-time employees making greater than or equal to $30,000, or, aside from all that, their name is Steve. In this case, the question of the employee's salary is never even applied to Steve. So, actually, if Steve were making less than $30,000, this query would still include him. So the only reason this query is actually correct in the end is because Steve is already making greater than $30,000 a year. So if we want to improve upon this query even more, and have this condition apply to part-time employees and to Steve, we could add in another condition, where employee name is equal to Steve and salary is greater than or equal to $30,000, or employee type is part-time and salary is greater than or equal to $30,000. Because the conditions with the AND keyword are logically grouped, the database will look at records with these conditions together or these conditions together. Hopefully that wasn't too confusing. Again, we'll go over this more in depth in a future lesson. That's it for this video, and I hope you enjoyed it. If you have any questions or comments, please leave them in the comments section down below. And don't forget to like and subscribe. Thanks for watching, and I'll see you in the next lesson.